Hello everyone. I welcome you all to Startup Academy, your online gateway to get success in ISS exam. This academy is exclusively for ISS, and today our topic would be partial autocorrelation function and all the four prior parts, which is autocorrelation functions, stationary, non-stationary, weak stationary functions, and autocorrelation function, which we have done in the previous lecture. If you are not aware of them, then you can watch that video, the previous lecture. And in today's lecture, we'll discuss about partial autocovariance function and the properties of autocovariance function and autocorrelation function. So let us begin. Now, what is partial autocovariance function? First, I'm defining it, and then we'll see what is the difference between partial autocovariance function and autocovariance function. So partial autocovariance function can also be denoted by PACF. So partial autocovariance function is defined as the correlation between xt and xt plus h after their mutual linear dependency on intervening variables has been removed. So what does this mean? That partial autocovariance function can be defined as the correlation or the covariance. The covariance between xt and xt plus h. The covariance between xt plus h after ignoring all the intermediaries or intermediate functions. Suppose we have to find out the covariance between, let us take an example. Suppose we have to find out the dependence of a commodity with respect to its lag value. Suppose we have a commodity like, let us take a book, or let us leave the book. Let us take a commodity such as paper. This is the paper. So suppose we are calculating its values, rate at time st, time st minus 1, time st minus 2. These are the three time periods that we want to. Suppose these are the months. This is January, this is February, and this is March. So autocovariance function tells us direct correlation between January and March, ignoring the February month if you want to calculate. And covariance function includes these intermediaries function. That is the main difference between these two things. So autocovariance function would be st covariance between st and st minus 2 directly. And if we have to calculate the covariance, autocovariance between xt and xt minus 1, this would be covariance between st and st minus 1 plus covariance between st minus 1 into and st minus 2 plus the direct one, covariance between st and st minus 2. So this gives us directly in one step, and in this we have to take intermediary steps to calculate our covariance. That is the main difference between partial autocovariance function and autocovariance function. For this, the lag value we have taken is 2. Lag value h we have taken as 2 because we are calculating for the month, this month and the month prior to this. Let us take these months as January, February, and March. We have taken the opposite one. So the lag value is 2. We have this time we are living in March, and we have to calculate the commodity for January months, 2 months prior to this. So the lag value would be 2. So our ST would be, the formula for ST would be phi 21 ST minus 1 plus phi 22 ST minus 2. This phi 22 is termed as, it gives, this coefficient gives the direct relation of st minus 2 with st, means the value of this month is how if this value is related to 2 months prior to this, how the price of the paper of this month is related to, or is what do we call that, or is affected by the 2 month prior price of the paper. So this coefficient will give us PACF, partial autocovariance function. Okay. Now, autocovariance function, suppose we have taken this. Suppose we have taken a graph. This is our, this is our graph of partial autocovariance function. So these are the lag values on the x-axis, and this is partial autocovariance function. So these lines tell us about the upper limit and the lower limit that is accepted to be in partial autocovariance function. So the values are, suppose like this. For 1 it is this, for 2 it is this, for 3 it is this, for 4 it is this, for 5 it is this. 1, 2, 3, 4, 5 for lag values. So the our function would be, for such graph, our function would be st is equals to phi naught s t minus 1 plus phi 1. Okay, let us take this as phi only, phi 1. Phi 1 st minus 1, phi 2 st minus 2, minus phi 3 st minus 3. That's it. Because these 4 and 5 value, the lag at 4 and 5 does not affect the PACF or does not cross the boundations. So we'll not take these two values and we'll consider only these three values. And PACF can also be negative. It can have a negative effect. Suppose the price of the paper this month, in January, was higher, and in because there were exams in the state, and paper price were higher because we all needed exam. All universities and colleges needed exams. But now the price has come down because in March there are no exams. So that affected our price of paper in the month of March, and hence it is decreased due to this process, or due to this university paper process. Okay, so that has a negative effect. Now there are some properties that we need to discuss about of autocovariance function and autocorrelation function. First one is autocovariance function. As we all remember, autocovariance function. which is termed as ACF, autocovariance function. Autocovariance function can be written as covariance between, like if I have to find the autocovariance with lag k, then this can be written as covariance between xt and xt plus k, or it can also be written as estimation of xt and xt plus k. This was the formula that we did. Sorry, estimation would be some minus mean also. Xt minus mu if the mean is mu, and xt minus t plus k minus mu. This was the formula for autocovariance. So the first property would be autocovariance of lag 0 would always be greater than equal to 0. Now how will we prove that? We know that variance of xt is always greater than 0, and variance of xt can be written as autocovariance between xt and xt, covariance between xt and xt, and this further can be written as covariance between xt and xt plus 0 greater than equal to 0, where the value of h is nothing but 0, lag value, and this can be written as autocovariance of 0 is greater than equal to 0, and hence proved it is always greater than equal to 0. Now the second property is autocovariance of any lag h modulus is always less than autocovariance of 0. We know that the covariance between xt and xt plus h is always less than equal to variance of under root of variance of xt and variance of xt plus h. This we all know. So I'm just replacing the value. Autocovariance between this is this, and variance of xt and xt plus h can be written as under root of variance of xt into variance of xt. This can be come out and written as autocovariance of h, and hence we can say that, and hence we can prove that this is the autocovariance, because under root is getting removed, so modulus will come on the other hand side. Okay, now the autocovariance function is an even function, the third property. Autocovariance function is an even function. So what does this mean? If we say that I have written autocovariance of h, I can write this as covariance of xt and xt plus h. Now we know that covariance of x a b is equals to covariance of b a. So I am just replacing both of them, xt plus h xt, which can be written as autocovariance minus h, and hence it is an even function. This was the property of autocovariance. Now moving on to autocorrelation function. Now we know that autocorrelation function is nothing but the autocorrelation function is represented by rho h is the ratio of autocovariance of lag h and autocovariance of lag 0. This was it. So the first property that we want to find is that rho h is always equals to rho k is equals to, sorry, rho 0, autocorrelation of lag 0 is always equals to 1. So if we put this in equation, autocovariance of lag 0 upon this only. So both the numerator and denominator will cut out and we'll get 1 only. So this was the one property. Then is the second property is autocorrelation of lag h is always less than equal to 1 modulus. Now from the previous property, we know that this autocovariance of lag h is less than equal to autocovariance of lag 0. So by dividing both the sides by lag 0. So lag h upon lag 0, 0 upon lag 0. So this would be nothing but autocorrelation with lag h modulus less than equal to 1. Hence proved the above. And the third one would be that autocorrelation is also an even function. Autocorrelation is an even function. So we know that the autocovariance is an even function. So we can write this like this, dividing both sides by autocovariance of lag 0. This would be autocorrelation of lag h and autocorrelation lag of h minus h. And hence this is also an even function. So this completes our topic, autocovariance, autocorrelation and partial autocovariance function. If you have doubt in them, then you can ask in the comment section, and if not, then you can keep on revising the topics and redo the topics. Keep on writing them along with, don't just see the videos, keep on writing them along with me, and you'll be thorough with the topic. And very much less topic is left in the time series. After that, we'll start with the new with the new topic, and keep on working hard and keep on doing the hard work. We have so less time and so much more to do. So whatever you are doing, I would suggest you all to keep on revising that and keep on doing it regular on a regular basis. All the best. Thank you.